Mercury, the smallest planet in our solar system, is a world of stark contrasts. Imagine this. Temperatures soaring to a scorching 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead. And then, as night falls, the surface plunges to a bone-chilling minus 180 degrees Celsius, minus 290 degrees Fahrenheit, colder than some regions of Pluto. Scientists are on a mission to uncover its secrets and learn more about the early solar system. So join me as we dive into the captivating world of Mercury. Welcome to Perspective of AI. Today, we explore our closest planet to the Sun, Mercury. Mercury's proximity to the Sun makes it a challenging target for observation from Earth. Its small size and faintness against the Sun's glare make it difficult to study with telescopes. But thanks to space probes, we've gotten invaluable close-up views of this mysterious planet. These missions have unveiled a world that is both familiar and startlingly alien. Mercury's surface is a desolate landscape, heavily cratered and scarred by billions of years of impacts. But beneath this barren exterior lies a fascinating story. A story of intense heat, volcanic activity, and perhaps even the presence of water ice hidden in the planet's deepest shadows. Did you know that Mercury races around the Sun faster than any other planet? It completes an orbit in just 88 Earth days. That's lightning fast. This incredible speed earned it the nickname the messenger god in Roman mythology. Pretty cool, right? But hold on. While Mercury may be quick on its feet, its rotation tells a completely different story. Believe it or not, Mercury rotates on its axis incredibly slowly. It takes a leisurely 59 Earth days for Mercury to complete one rotation. That's almost 2 months. This means that a single day on Mercury from sunrise to sunset lasts for 176 Earth days. Imagine that. This peculiar rotation pattern is due to the Sun's gravitational influence on Mercury's small size and proximity. Fascinating, isn't it? The combination of a short year and a long day creates some unusual effects on Mercury. Let's dive into one of them. For example, the Sun appears to rise in the east, set in the west, and then briefly rise again in the east before finally setting in the west. How bizarre is that? This strange phenomenon occurs because Mercury's orbital speed briefly exceeds its rotational speed at certain points in its orbit. Mind-blowing, right? As the closest planet to the Sun, Mercury experiences some of the most extreme temperatures in our solar system. During the day, temperatures on the surface can soar to a blistering 430 degrees Celsius, hot enough to melt lead. This intense heat is due to the Sun's close proximity and the lack of a substantial atmosphere to regulate temperatures. But wait, as soon as the Sun sets, without an insulating atmosphere to trap the heat, Mercury's surface cools rapidly. Temperatures plummet to a bone-chilling minus 180 degrees Celsius during the long Mercurian night. This extreme temperature swing between day and night is the largest in our solar system. These wild temperature variations have a profound impact on Mercury's surface features. The relentless cycle of heating and cooling causes the planet's surface to expand and contract, leading to the formation of cracks, ridges, and other fascinating geological formations. Mercury's surface is a testament to its violent past. Billions of years of bombardment by asteroids and comets have left it heavily cratered. Resembling our own moon, these impact craters range in size from small bowl-shaped depressions to vast impact basins. Hundreds of kilometers across, one of Mercury's most prominent features is the Solaris Basin, a colossal impact crater spanning 1,550 kilometers in diameter. This impact basin is one of the largest in the solar system, formed by the impact of a massive asteroid. Billions of years ago. The impact that created the Solaris Basin was so powerful that it sent shockwaves rippling through the planet, creating a region of chaotic terrain on the opposite side of Mercury. Another distinctive feature of Mercury's surface is the presence of lobate scarps, long cliff-like formations that stretch for hundreds of kilometers across the planet's surface. These scarps are thought to have formed as Mercury's interior cooled and contracted, causing the planet's crust to buckle and wrinkle. A wispy veil, Mercury's exosphere. Let's dive in. Unlike Earth with its thick atmosphere, Mercury has a delicate, tenuous exosphere. Fascinating, right? This extremely thin atmosphere is more of a wispy veil than a substantial envelope. Imagine that, it's constantly being replenished by solar wind particles and surface material ejected by micrometeoroid impacts and solar radiation. A never-ending cycle. The exosphere is composed primarily of sodium, potassium, and other volatile elements. Quite the mix. These elements are blasted off the surface by the sun's radiation and the impact of micrometeoroids. Boom! The weak gravity of Mercury is unable to hold on to these particles, and they are constantly escaping into space, forming a long tail of material trailing behind the planet. A cosmic tail. Despite its thinness, Mercury's exosphere plays an important role in shaping the planet's environment. Who knew? It interacts with the solar wind, creating a magnetosphere that helps to deflect some of the charged particles streaming from the sun. Amazing, isn't it? One of Mercury's most fascinating secrets lies hidden beneath its surface. Data from the Mariner 10 and Messenger missions revealed something astonishing. Mercury has an unusually large metallic core making up about 85% of its radius. This is significantly larger than the cores of the other terrestrial planets in our solar system. The exact composition of Mercury's core? Still a hot topic of scientific debate. However, it's believed to be composed primarily of iron and nickel, much like Earth's core. And guess what? The presence of a liquid outer core is responsible for generating Mercury's weak magnetic field, which is about 1% the strength of Earth's magnetic field. The origin of Mercury's massive core? Now that's a mystery. One theory suggests that a giant impact early in the solar system's history may have stripped away much of Mercury's outer layers, leaving behind a planet with a disproportionately large core. Another theory proposes that Mercury formed closer to the Sun, where the intense heat vaporized some of its rocky material, leaving behind a planet rich in heavy elements. Fascinating, isn't it? Despite its scorching proximity to the Sun, Mercury hides an astonishing secret: water ice. Back in the early 1990s, radar observations from Earth unveiled bright, highly reflective regions within the permanently shadowed craters at Mercury's poles. These regions are so cold that the ice doesn't sublimate, even in the vacuum of space. The discovery of water ice on Mercury, it was a jaw-dropper for scientists. But Mercury's unique combination of a tilted axis and those permanently shadowed polar craters creates perfect spots where water ice can stay stable for billions of years. It's believed that this ice was delivered by comets and asteroids that smashed into Mercury early in its history. The presence of water ice on Mercury has huge implications for our understanding of water distribution in the solar system. It hints that even the most seemingly inhospitable environments can harbor this essential ingredient for life. Fascinating, isn't it? Exploring Mercury has always been a challenge due to its proximity to the Sun. But that hasn't stopped us. Several daring space missions have ventured to this enigmatic world, providing valuable insights into its mysteries. NASA's Mariner 10, launched in 1973, was the first spacecraft to visit Mercury. Imagine that. It performed 3 flybys of the planet, mapping about 45% of its surface and revealing its heavily cratered terrain, thin atmosphere, and surprising magnetic field. Fast forward to 2011, NASA's Messenger spacecraft, short for Mercury Surface, Space Environment, Geochemistry and Ranging, became the first spacecraft to orbit Mercury. Messenger spent 4 years orbiting the planet, collecting a wealth of data about its surface composition, magnetic field and tenuous exosphere. Incredible, right? These missions have revolutionized our understanding of Mercury, revealing a world that is far more complex and dynamic than we ever imagined. And the journey isn't over yet. BepiColombo, a joint mission by ESA and JAXA, is currently en route and will arrive in 2025. Its goal? To uncover even more about Mercury's core, its magnetic field and the mysterious water ice. Stay tuned. Studying Mercury is absolutely crucial for unlocking the secrets of our solar system's formation and evolution. As the innermost planet, Mercury offers a unique window into the conditions that existed during the early days of our solar system. Isn't that fascinating? Its unusual characteristics like its massive core, delicate exosphere and surprising water ice, provide invaluable insights into the processes that shaped the inner solar system. Wow! By delving into Mercury's mysteries, we can uncover more about the distribution of elements in the early solar system, the pivotal role of impacts in planetary evolution, and the fascinating processes that drive planetary magnetic fields. Isn't that intriguing? Mercury's close proximity to the Sun makes it an ideal laboratory for studying the effects of space weathering and the dynamic interaction between a planet's surface and the solar wind. How cool is that? Moreover, understanding Mercury's unique traits can help us refine our models of planetary formation and evolution. By comparing Mercury to the other terrestrial planets, we can gain a deeper understanding of the factors that led to the incredible diversity of worlds in our solar system. Isn't that amazing? Why does Mercury matter? Because it's a time capsule, a planet frozen in time, holding clues about the solar system's violent past and formation. Understanding Mercury helps us learn how planets evolve, why magnetic fields form, and whether similar rocky exoplanets exist around other stars. Mercury may be small, but it's a world of mystery, extremes, and cosmic history. And with new missions on the horizon, the secrets of this tiny planet are just beginning to unfold. Want to explore more cosmic wonders with us? Smash that like button, subscribe, and tell us in the comments, what's the most mind-blowing fact about Mercury? Until next time, stay curious and keep exploring. Subscribe and follow on YouTube, Perspective of AI,